Everyone, based on what part of the world you're joining from. Welcome to today's webinar covering applications of RSTRENG software for corrosion and metal loss assessment. My name is Adam Schindewolf, and I'm the Product Marketing Manager here at Technical Toolboxes. And today, I'll be your host for this webinar. I'm going to start off by sharing the agenda for today's webinar, just so everyone knows what to expect. This is a joint webinar between Technical Toolboxes and PRCI. So briefly, we'll be starting things off by introducing our speakers and sharing some background behind the organizations that we work for. We're going to be moving on to then examining RSTRENG as a technical concept, looking at what is RSTRENG, how do ASME B31G calculations work, and then moving on to how is RSTRENG used, looking at some of the use cases and benefits it can bring for your organizations and engineering teams. Then we're going to be briefly talking about the Pipeline Hub software platform, which is where the PRCI RSTRENG software is hosted. And then we'll be moving on to doing a more in-depth demo of the software. So everyone will be able to see how the software actually works and how it can be leveraged and some of the value-added benefits of the platform and how your team can extrapolate on this data to provide better decision-making. Moving on, we'll start to cap things off with the next steps, how to move things along if you are interested in gaining access to the software that's being shown, either as part of your PRCI membership or through your organization. And then at the end, we'll be capping things off with the Q&A. I will ask that any questions that arise as we go through the webinar to be held until the Q&A at the end. If you'd like to submit a question, feel free to enter it in the chat box or submit it through the questions box. We have had a few questions already introduced by email as we were promoting the webinar, so we do have a few to go off of, but we would love to hear any questions that arise as we go through the webinar, so please submit those. Moving on, I'd like to introduce our speakers. The first one is Joe Pikas. He has 50 years of industry experience working for pipeline operating companies, engineering firms, and technology providers, the longest of which was with Williams. He's also Technical Toolboxes Integrity and Corrosion SME and an SME behind several of our corrosion applications. And he's the author of 50+ papers and articles and recipient of the AMPP Distinguished Service Award. To build on that, he will be speaking at the upcoming AMPP event in March in Denver. And most recently, he had a paper published this month in World Pipelines titled Under Pressure. Our other speaker is Gary Hines. For many of you, he's going to be a familiar face, but he's the VP of Operations at PRCI, where he handles a lot of the day-to-day activities. Prior to working at PRCI, though, he was the VP of Learning and Professional Development at the Southern Gas Association and has held several engineering roles at Southern Star Central Gas Pipeline and at Williams Companies. Moving on, I'd like to provide a kind of brief introduction to Technical Toolboxes because some people may have come, as current customers of Technical Toolboxes, or some people may be coming from PRCI member companies that may not work with Technical Toolboxes. So to briefly introduce the company, Technical Toolboxes offers a comprehensive software and continuing education solution to the industry. We combine internal R&D while partnering with industry leaders to integrate intellectual property sources and key data assets. One of these key partners would be PRCI. In the presence of an ever-changing regulatory compliance environment, we help to keep pipeline engineers, inspectors, and consultants up to date. And we integrate the information that we get from these consultants and from our partners onto the Pipeline Hub engineering platform to add value to many of the most widely used engineering applications on the market. Through our software platform, we help companies improve their engineering process standardization, improve engineering team collaboration, improve engineering teams' efficiency, and their data integrity. We'll be going in more to some of these details into how our software platform helps to accomplish these, but overarchingly, these are our missions as an organization. So leading in, I want to allow Gary to expand a little bit more on PRCI as well. So I'd like to hand it off to him now.
Adam, thanks. Just a quick audio check. Make sure you can hear me okay.
Yep, you sound great, Gary.
All right, sounds great. Again, Adam, thanks, and certainly welcome to everybody who's joining today. Certainly for those that are PRCI members, as Adam said, a hearty hello to you for the day. And for those that we haven't met, it's a pleasure to virtually meet you, at least here on this webinar today. As Adam mentioned, I wanted to cover just a few things from I guess what I call a high level of PRCI. Again, for those that may not be familiar, and also for those that again are PRCI members, just a reminder of what our mission is and what we stand for and what we do. I won't read through the mission statement here, but I do think it's important for us to make sure that we stay grounded and stay centered on this. A few words that I would point out is certainly the collaborative nature that we deliver relevant applied research. And also, I think today's webinar really provides us a great example of innovation. Certainly, RSTRENG has been around several years now, and we could come up with several other webinars, which I'm sure that we will do for the months to come, for additional innovative products that has gone to market. But we just want to make sure that we stay centered on this, on the collaborative nature, and also on the innovative approach, and again, more specifically, applied research. It's not just a matter of doing research for the purpose of doing research, it's actually doing application of research. So I think that's really important. And really, I think that's what our members strive for every day, is they've got a problem, they've got a situation, they've got an issue, they come together, they collaborate and look for a common solution that is best for the entire energy system. And we'll talk more about what that means within PRCI itself. We'll go ahead and move to the next slide, and would be remiss if I did not mention our 70th anniversary this year. And as I was preparing for this webinar this morning, I was thinking back a bit more. Certainly, this organization has been around a lot longer than I have, so I think it was important for me to go back and do some reviewing for this topic today, and reminding myself, as well as our members, as well as anybody else joining today, that PRCI was founded out of the American Gas Association through the Pipeline Research Committee, PRC portion, and again for the same purpose of we need to solve a problem. So from many years ago to today, we still do the same thing regarding looking for solutions for the entire energy industry as a collaborative effort. If we move to the next slide, that just gives you some perspective of the things that we do and where we are engaged, and the diversity of membership that we have. Really proud of this from the perspective that the international component in that lower right-hand corner, even though about 60% of our members of our mileage is represented in the North American region, we do have representation across the Middle East, across Europe, Australia, and Asia as well. So problems that they may have in other continents, that you may have in other continents, may be unique, or it may be something that other continents just haven't come across yet. So I think that diversity, again, and that collaboration really helps us in bringing these products forward and bringing them to the marketplace. And then just real quickly on the last slide for PRCI overview, this just gives you a bit more of a quantity count of the breakdown of membership that we have. And you can see there, again, based on counts, we are heavily North American, but we do have non-North American representation from the organization. And really, about half of our members are the pipeline operators, and then the other half are the associate members, the service providers, the consultants, that certainly are a big part of our industry and what we do. And also playing a part of that is pipeline industry organizations that are members of PRCI, and you can see those listed here for who make up the organization. So again, not a lot of time to spend on that, but I do think it's a good reminder for all of us to know, where does this content come from? And it's not just a couple of folks sitting in the back room and having some harebrained idea. It's actually advanced globally, and typically what is a problem for one is a problem for another, and that collaborative nature, and again, developing applied research, which again, I think we've got a great example here on this webinar today of how that works. That's really what we strive to do every day. The last thing I really wanted to cover before we get into the meat of this content is as Adam talked about in the beginning on the next slide here, is what's the integration look like between these two organizations? You can see and read through the comments there, but I'm going to focus on that linear chart on the bottom of the screen there, and moving from left to right, as we were just talking about, and a challenge is identified, multiple people start coming together and saying, well, yeah, I've got that same problem, but this is how we've been dealing with it. How do you deal with that? So that's the collaborative nature. And essentially, PRCI provides a funding mechanism. I think that's our real strength, is obviously the collaborative nature, but also just the funding mechanism where members get to leverage their dollars. So if one member has $100,000 that they want to put in, and they can find 9 others, they can do $1 million worth of research work. So that's the leveraging opportunity. And through that collaborative nature of looking for an R&D solution, we eventually get to an output of some kind. And now sometimes that output is a simple white paper, it's a study, it's a state-of-the-art advancement of where we're at, it's a gap analysis. But in this case today, what you'll hear is there are times that the output certainly is some sort of assessment tool that then becomes a software application. Again, going back to some of the original roots of this software, it was Microsoft DOS. Of how it was actually deployed. And we'll see today how that certainly has been more operationalized and advanced and integrated with what Technical Toolbox provides. But that's really the flow of how things work. And then just as that last item there is go to market, we've got some new products that we're doing testing on right now that I really hope that we can get out to our membership through Technical Toolboxes. And obviously Technical Toolboxes can let their clients know about the additional software applications that are rolling out the end of this year yet, as well as in the next year. So this is a great example today, if you will, a long-standing assessment tool that's been well recognized from a regulatory perspective as well as from an industry perspective. And there's some great things coming now that will continue to advance this in our model that we have regarding, again, as that linear chart there at the bottom shows, from identifying a challenge, allocating the funds and leveraging funds through membership, coming up with a solution, and then looking for the value. And really what I think Joe will do a nice job of is just showing how the assessment tool can then be operationalized into something greater than even what it was originally designed for, with assessments within the pipeline system. So I'm going to pull up at this point and turn it over for the real meat of this conversation regarding RSTRENG, and be back in a bit for some Q&A and go through that. So I'll turn it over and let's get into the actual RSTRENG component and the details of that.
All right, as Gary said, we're going to be moving on to Joe Pikes' breakdown of RSTRENG as a technical concept. So without further ado, go ahead and take it away, Joe.
Okay, well, welcome everybody. And first thing I want to point out is let's just talk about how RSTRENG came about. Back in the early days, when we were using B31A, and I'm sorry, B31G and modified B31G, and even before that, we were using the Patel calculations. They were in a big book. Everything was pretty conservative. There was a lot of, how could I say it, excessive repairs and replacement of pipe using these very conservative calculations. And in the late 80s, it came about that the industry came to PRCI and said, hey, we need some help. Because of all these repairs and replacements, and they're costing, you know, there was a lot of cost involved. And that's how RSTRENG got involved. And I happen to be on the RSTRENG task group with PRCI at the time. And I worked with Mr. Kiefner, Dr. Kiefner, and Pat Feith, who headed up the program. And there was a group of industry experts, including myself. And I just want to let you know that what differentiates RSTRENG from the others, it's a level 2, whereas the ASME B31G, the original and a modified, were level 1s. And what's the difference between like a level 1 and a level 2? Well, level 1 is just taking the maximum length of the defects, we'll call it metal loss, which we're talking about corrosion basically, whether it's internal or external, and the maximum depth at some midpoint. And this is what made it extremely conservative. And in some cases, it may not be because of the way the calculations were set up. And the idea was to come up with something that is going to work for industry. Whereas level 2, RSTRENG's a level 2, it does multiple increments, or basically it mimics the morphology of the pitting itself, particularly the river bottom. In other words, this is what we're dealing with, is the deepest point as you're going along the pipe axially, okay? Well, that came about in 1989, okay? So picture that, you know, compared to ASME coming into place in 1968. And then B31G didn't come out until 1984. So there was a lot of time that went by. And then, of course, the regulators at the time is called Office of Pipeline Safety, OPS, which we now know as PHMSA, came about. And both 192 and 195 picked it up and put it, you know, adopted in a regulation. So it is a PHMSA approved, so to speak. At that time, Technical Toolboxes was putting out discs to the industry. That's the only way we could get it distributed. But the most important thing is, how does it work? You know, we say it's the more or most accurate. There is, of course, other research that has more that Gary mentioned, that there are other techniques too. In fact, there's multiple techniques that each company, some companies have developed, from API to shell to others. So, and we offer some of those in our RSTRENG Plus program. So just to let you know, but it presently at this is the most commercialized, accurate method that we know. Hopefully we keep changing and getting better at what we're doing. So you can see, when you use a level 1, a B31G calculation, it's just 2 measurements, and we need to keep that in mind. Well, you know, in what really promoted RSTRENG, you know, when it was first released, it was not quite accepted like anything new. You know, everybody thought it was too liberal and everything else, until about mid-90s. You know, when the corrosion evaluation methods really started taking place, and people and the pipeline operators begin to realize, you know, what's going on. And not to get a little technical, but you know, the B31G just uses a single parabola, you know, with a 2-term fullest factor, and says, yep, that's the deepest point in that middle, even if it's, you know, upstream or downstream. And the same thing with the modified. It used represents an effective area with a modified rectangle using a 3-term fullest factor. So they tried with those, but unfortunately, it didn't work out. Next slide, please. Adam, next slide. There we go. Okay. So how is RSTRENG used? Well, it's used quite a lot today. You know, because of the cost of materials and extensive labor, you know, we got to get it right. And one of the things is the tool will help prioritize, you know, the sections of pipe under investigation. And this is important, you know, because we're looking at a way to get the best bang for our buck. In other words, we need to determine the optimal approach for repairs. You know, do we need to do, you know, can we put a composite sleeve on, or maybe we need to do a pressurized type B sleeve. You know, these are the kind of things we need to be thinking about. And is there any cracking associated with the metal loss? And these are really important components to notice, the pigging companies can't always tell you that there's cracking with, associated with corrosion, and there is, and this is why we need people that understand metal loss defects and how they're associated with other damage on the pipe, because it just doesn't happen all by itself. Usually there's some factors that are involved in it. Of course, it goes from coating damage to stresses on the pipe, overburden, and things of this nature. This is the reason why we get into so much so many issues with with the pipe itself. And you need to consider that RSTRENG is developed for only the primary stress factors, nothing outside of that. In other words, with as I just mentioned, the type of other defects going on. And then how do we handle welds and things of this nature? That's another factor that needs to be considered, in the metal loss. So we're dealing with many things. The nice thing about external is we have access to the pipe under most conditions. However, internal, how do we handle that? And that has to be looked at as a separate operation because of ongoing corrosion. So you need to consider some of these things when you're doing your assessments. And the nice thing about the tool, it'll accept both remaining wall or pit depth, and we'll talk about that in a couple minutes. So this is why RSTRENG, once it got started, it got a little bit of it was a little slow coming out of the gate, but like anything new, back in 1988, 1999, the industry needed to get confidence in the tool, what this assessment tool does. So the nice thing is it is a good solution. We also combined it with to determine reassessment intervals, remaining life and metal loss. We could do engineering critical assessments to limit investigative digs, and of course, it's verification. This is the key. You get a smart pig run, and what's the first thing you need to do? Do you trust everything that the pig run has done? Remember, it's plus or minus. It's 80% accurate, plus or minus 10% of 80% of the time. So keep that in mind, that we need to think about why we need to do investigative digs before, right after the inline inspection, so we could do our prioritization and things of this nature. And what's the reason for prioritization? What are our immediate schedule and monitor digs? So keep that in mind. Next slide, please. Okay, I think this is yours, Adam.
Yep. So now, thank you, Joe, for that breakdown of RSTRENG as a technical concept and some of the ways it's applied. Before we go into the actual software demonstration portion, where Joe will be, showing how this software works in our environment and the different outputs and the interface, I quickly wanted to cover the Pipeline Hub, which is the software platform that actually houses the RSTRENG application, along with the rest of our data, reporting, GIS, and other engineering tools. It's important that we cover this now because Joe will be leveraging several of the Hub's features and integrations that really help to bring our engineering tools kind of to the next level of utility and helps engineering teams accelerate project schedules, lower expenditures, and ultimately reduce risk. So at a fundamental level, the Pipeline Hub is the platform our users log into in order to access their engineering tools. As Joe gets into the demo, you'll see that all of our engineering apps can be accessed through the blue ribbon across the top of the software. But what may not be as readily apparent are the value-added benefits that the platform brings to each of these tools, including the RSTRENG tool. The Pipeline Hub is an integrated data environment, or an IDE, which means that pipeline data can be easily imported or configured, managed and centralized, and leveraged by any application in the environment. So things like data integration and integrity, improved productivity and collaboration, automated reporting, knowledge transfer, process standardization, and workflow automation are all applied to each app in the Hub. Oops. Sorry about that.
Okay, next slide.
Okay. There you go. So now we can launch into
Okay.
the actual software. So I'm going to go ahead and
Okay. Could you switch it to the to make my screen live?
yeah, absolutely.
And that'll be screen number 1.
All right.
You guys see my, okay, here, show my screen. You see my screen with the RSTRENG program on it?
Yes, we can.
Okay, okay. Not the camels that I have in the other screen when I was over in Algeria. Okay. All right. So what we have here is we have our hierarchy panel. Okay. And this is where we put our information. This is all fictitious information. So don't take it that I use somebody's name or something like that, an old company I work for or anything like that. I'll just move that up a little bit. And over here is the RSTRENG program itself. And one of the things about the hierarchy is that as we create cases like this, they could go into the into your particular GIS systems. Okay. So just want to point that out. Okay. And then over here is where we input our data. You know, this is a 24-inch line, 375 wall, and et cetera, and what it's good for. And then you can see your profile graph. And this is the RSTRENG Plus program. And here's the PRCI calculations, what we call the PRCI calculations. The RSTRENG is called the effective area. And then here's where we bring the data in. And then here's the non-PRCI calculations. And then we go down here, and then I'm going to show you, we're going to come to a wheel load analysis where somebody's crossing the pipeline with a wheeled vehicle, and then where it's located in the ArcGIS system. So all of this is integrated. So I just want to show you that. But so let's start from this point here. We're going to go back up here, and I'm going to just give a high level overview. In this case, this is one of the programs where we have multiple effective areas. Remember, most calculations only tell you the deepest. So if you have long length pitting such as this, it's about 115 inches long. And I know nobody has 115 inches, but just in case you did run into a situation, or say 40 or 50 inches, you may find that you may have multiple effective areas. And this could be a big thing. How do we repair? And what we come up with was a process. We didn't change, no calculations are changed or anything like that, where if you didn't want to put in an entire sleeve for the 115 inches, or you just wanted to put the effective areas that are impacting. And remember, we're dealing with the pressure. You know, everything is based on pressure, and the most important thing is we calculate the burst pressure first, and then we go from there. As you can see in the bottom here, we determine the maximum safe pressure. And of course, this is a class 1 or 0.72 design. Okay, so as you can see, it's a 52,000 yield pipe, and here's the MALP. Okay, and here's the P design. This is Barlow's formula. Okay, design formula. So many companies operate a little bit less than what it's designed for. Could be different components in the pipe that are restricting the pressure, or even the compressors or pumps they can't get up to that pressure. But the whole point is this is where you put your information in here. And then also we have the corrosion growth rate. Okay. So this is what we're and where does that come from? That could come from your pig run, it could come from coupons, it could come from your soil resistivities, any type of way that you make your assessments on coming up with corrosion growth rates or actual measurements. So how would we do? What if we just wanted to? We're in the process of saving money. So if we wanted to make the determination, you notice here's your safety factor. So for 0.72 design, if you take this reciprocal of 0.72, it comes out to be 1.388 or 1.39. And you notice all of these are below 1.39. So it fails. So between 94 to 103 inches, that's the deepest. And then between 10 and 19 inches, and then 59 to 67 inches. So if we made repairs there, and this is how the automated process works. Just watch this, and we're returning it back to parent metal. So if 3 repairs were made at these locations using various sleeves, you wouldn't have to do a if the pipe was out of round or things were not straight, maybe you have to go this route. We're not saying it's for everybody, it's just an option. So just wanted to point out that we had that capability to do that. And that was requested by industry. And they said, you know, we just have situations where we just can't put one long sleeve in there, okay? So you have that option, and then we just bring it back. And if we want to do a report, I could bring something like this out. I'm saying I'm going to do the 3 of them, or maybe you just want to do the 1. It's up to you. And we could create a report, and lo and behold, it'll run and create our little report here. There it goes. And so here's our information. This is what it looks like. I just want to give a quick overview. This is an RSTRENG training class, and we'll take it from that point on. But and it'll list everything out and go from there. So this is how quickly it can be done. This is the nice thing about something like this. Now let's take a case like I'm going to do dig number 2, and I'm going to bring this up rather quickly, and you can see this is an investigation. Yes.
I'm just going to pause for just a second because I think the screen share is freezing a little bit.
Oh, okay.
So I'm just going to switch presenter off of you for just a second, and then I'll bring it back to you.
Oh, okay.
That'll fix it.
Sorry about that, folks. Okay.
No problem. It only happened at the end during the report.
Maybe maybe the report. Well, I have another report already printed, so we don't have to go through that. Maybe that's what messed it up. But well, here's something a little bit less, and you could see this situation where it passed the RSTRENG, but it failed the B31G. And this is the nice thing about these programs. We have it color coded. You could easily follow along. You could see all the calculations if you want. This is your option. And then also we also calculate the failure pressure ratio, the time to unit failure, the remaining life, and then of course your reassessment interval, and then also the potential impact area. So one of the neat things about a program like this is it gives you these options in here. And I think I printed one previously to this. Oh, that was my previous session before this one. Let's go to this one. I was dealing with another company up in the Northeast. Anyway, you could see here, here's the same information, everything's in here. And you notice everything passed, it's above 1.39, except for the original ASME B31G. Here's the number of increments right here, and the pit depth, and the in mils, and the percentage. Just want to show you that. And then you can put in documents. We allowed to put in two 10 meg documents, and I just drew this in, and then we go from there, and I drew an HDD crossing in there, just for demo purposes. But this is the capabilities of how these programs have progressed. Now, here comes the really cool thing. We said we could put it in our hierarchy panel, okay? Also, what they didn't say is I could bring it in and put it into our ArcGIS mapping. And if I want to bring up another program, like wheel load analysis, and we're going to determine the stresses on the pipe, and we have an R-string calculation right at that same spot. Isn't that neat? Who would have ever thought about that? So one of the things we could do is come up and turn the metal loss on, okay? And here's that same crossing. This is a different one, okay. Well, that doesn't make any difference. I have a choice here. So I think it's dig 2. Let me try dig 2. Yeah, there it is. Okay, there's dig 2. So I know at dig 2 that we're at the same location. Okay, nice. You could pick whatever it is, and we're gonna run this calculation. And you can notice it's below the maximum. I'll run a calculation, and it's below the maximum combined stress. However, if I include the metal loss in there, just check the box. Now that I got the R-string calculation in there, lo and behold, it fails. So the benefit of taking something that PRCI developed back in 1989, it was accepted by the regulators I think the same time, makes this a truly integrated system where you could bring it up not just on our ArcGIS, but your own, and you can manage your digs and things of this nature. This is where the power comes in. It's not just calculating and saying, yeah, it passed, or it didn't pass, or it did this, or it did that. What we're doing here is we're bringing up things that could impact other calculations that you do day to day, for operations, or even for design, or whatever it is. The power of this tool really comes to shine when you can integrate it with any of these tools up here, from design tools to crossing tools to whatever. And this is where we see true integration beginning to take place on crossings, uncased, cased, whatever the situation may be. So with that, we are going to have a Q&A session, and this is where we could switch to remaining wall. We have where you could set it up yourself. It gives you a lot of capabilities. This is where we put the corrosion growth rate. This is where we import an Excel file to bring the data in. Okay, and so whenever that turns, whenever this little calculator turns green, we need to hit calculate if we change something. So this is the nice thing about, you know, a tool like this, that you could bring the data up either through the mapping, through the hierarchy, or create your own data. And one of the things, if you're doing multiple digs, is the power to go and do, if you're going to go to dig 3 and you're going to create a dig 3, all you have to do is save as and say dig 3. All of my data input is the same except for the profile of the new metal loss coming in. And so again, you could change this to dig 3 very quickly and re-import. We could save it and then just change the data accordingly, re-import the data. Rerun this again, and I'll cancel that. But the whole point of this operation is the ability to make these changes so quickly, and this is where the true power comes in. So with that, is there any questions? And we'll leave it to Q&A.
While we have a second, actually, there was a question posed about this. It was a little bit earlier, so you may have addressed some of this, but while you have the software pulled up, it could be a good idea to address it. And it was asked, can you please show remaining life calculations and the factors considered by this software? I know you've gone through that a little bit, but maybe you could touch on that one more time.
Oh, okay, yeah. Well, let me run this again. I'll bring this one up. There we go. Okay, so one of the things is on the remaining calculations, it's based on your corrosion rate, which I mentioned earlier. Okay, and this is one of the key factors. This is where you have to get your pipes accuracy it's going to be different for each pipe. And anytime you make a change, what if it was just a recoat to fix this? Well, all of a sudden your corrosion rate goes down. You know, you took care of that issue. So my point is it could be done through successive pig runs. It could be done by coupons if you have coupon test stations out on the right of way. It could be done by taking soil resistivities and analyzing them to determine the corrosivity of the soils and things of this nature. So there's a whole myriad of ways to assess your corrosion growth rate. So it's based on this number here. So if I change this to 1 mil per year, or this is inches per year, but 0.001 is 1 mil per year, right? And I recalculate, you know, this, okay, all of a sudden my corrosion rates go, oh, it's way down, and all of a sudden my remaining life is it's a lot greater than than we thought. And here's the key, and this is a regulation thing. It's called a half-life calculation. And so one of the things that you must think about is that you're dealing with the half-life calculation. However, if you don't know what your corrosion growth rate is, unfortunately, you're gigged to a number like this. And lo and behold, let me go up and calculate again. All of a sudden, that corrosion growth rate plays a very important role. So it's important to get that one right. So I'm going to slide down here, and you can see instead of 135 years, your time to failure has been reduced to 8 years, and all of a sudden your reassessment intervals down to 4 years. So it's extremely important that these assessments that are made on the pipe, whomever's doing them, that they understand what this value means. So if you have nothing to start with, you have a default to something like this. So it behooves anybody to go and say, yeah, we better go out and do our homework and get a real true corrosion rate. And the same thing applies to internal corrosion or anything like that. This just doesn't mean, so you could have a different corrosion rate for external and one for internal. And so you need to be looking at everything in that situation. That was a great question.
Okay, before we move on to follow-up questions, I'm going to quickly change myself back to presenter to pull up the slideshow.
Okay.
Okay, I believe it should be back on the slideshow now.
Yep.
So quickly, before we move on to the rest of the Q&A, I wanted to quickly cover next steps. So as we said, stay for the Q&A session. It's going to continue from here. We have a few more questions that have been submitted. If you're interested in finding out how to gain access to the software, feel free to reach out to info@technicaltoolboxes.com, and we will follow up with you from there to look at your PRCI membership level or see if through your organization we're able to provide it to you. To clarify on that, any member organization that is a full-fledged PRCI pipeline member is able to access the software for free. And if your company is only at the technical committee membership level, then if you are a member of the Corrosion technical committee, then you're also able to get this software for free. If your company isn't at that level or you don't know, please reach out to info@Technical Toolboxes and we can see what we can do for you. So moving on to the next Q&A question. The first one that I see posted is, can corrosion assessments be made at irregular intervals with RSTRENG? Joe, could you take that one?
Absolutely. Yeah, one of the things, if you don't mind, you could bring up that last slide. We could use that as there we go. One of the things with normally companies will use regular increments, like over here on the profile. It's 2 inches, 3 inches. It could be 1/2 inches, 1/4 inches. With some pieces of equipment, such as optical imaging, you could get down into as low as millimeters, micromillimeters, if you want. So it doesn't make any difference if it's on a regular basis or if it's on a irregular basis. It could be maybe you're just picking the deepest points, along the axis of the pipe. And this is one of the things you could do. The only thing is you gig yourself by extending some of these intervals. So if you keep them short, like many companies are now using 1/2 inch. Why? They were using 1 inch, but they're finding that they get a better assessment by doing 1/2 inch. It may take a little longer if they're doing it manually, but if they could do it with optical imaging. And what I mean by that is 3D laser or 3D structured light. Those are tools that are used out there to make these assessments, and many of them are good to plus or minus 1/1000th or 1 mil. Okay, so keep that in mind. These tools could make those kind of assessments. Great question. Thank you.
Awesome, thank you, Joe. Another question I see posted is, should corrosion pitting reference for the RSTRENG program always start at the beginning of the pitting?
Yes, absolutely. So here we have 0. Now, as a user, and you're in the field, you're going to be measuring from an upstream weld or downstream weld, depending on which one is closer. And so you may be so many meters or so many feet away from the upstream weld, but the pitting should start for the purposes of the program at 0. Now you could go to your comments or your notes in the program and put in, you know, that the dig sheet said it was 3.1 meters away from the upstream weld, approximately 10 feet, 2 inches or so. So you could do something like that and say, you know, that the reference weld was at that location. However, the pitting started right at that point, and then the actual length, because we're really focusing on the actual length, you know, whatever it may be. So we think it's that important. This is a typical pit that you would see, typical V. You know, that this is why they would. This is why B31G used something like this as normal galvanic type pitting. But guess what? We have other factors out there called straight currents, whether they're AC. We have a lot of that going on. You know, and you know, where we're paralleling power lines, and DC dynamic being a rail. Or static from other companies' rectifiers. So these are the kind of things that need to be considered. So keep in mind, there's just many influences of and morphologies of pitting. I do a training class on, actually I got one coming up this Friday, I believe, on RSTRENG. So keep in mind that that we have these different morphologies to deal with. So this is why we start with 0. Okay.
Okay. Another question that I can take actually is the hierarchy panel standard with the hub, or is it an extra module? So it is considered a separate module as part of our hub navigator little suite, and it includes the hierarchy panel, which is obviously a really popular feature, along with a few other kind of data tools. So that would be that would go alongside RSTRENG, but it isn't included standard in the hub, although it is very popular. Another question is, how accurate does RSTRENG work with MFL ILI data?
Well, I should say it the other way around. One of the things is that RSTRENG should, it's not the calculation, it's the measurements in the field. Okay, and so the program, you have multiple ways to, like I say, to measure pitting. You could do it manually, and you could do it very correctly with some of the better manual pit gauges. And then we have optical tools that are used, optical imaging, and they're plus or minus a mil, and so are some of the manual tools, plus or minus a mil or 1/1000th of an inch. And here's the key. You know, when you get long length pitting, like I mentioned, I showed you before, that 115 inches. You know, what are the interaction rules that you used? You know, interaction rules play a role with determining that length. And some companies use interaction rules such as 6T circumferentially and 3T axially, or 1 inch, whichever is greater, you know, to be conservative. So, you know, that seems to be the more common one in the US. The Canadians have their own interaction rules. And unfortunately, or fortunately for the US, I don't, either way you can look at it, we have a variety of interaction rules because there is no regulations on them, except ASME B31.8 and 4 that you must use interaction rules a minimum of 3T and 3T, and many companies determined that they wanted to go that route of 6T and 3T. However, they get their data from the pigging company, something like 12T and 12T, and it's because it's boxed up. And so you're talking apples and bananas sometimes. So it's and you have to remember the MFL tools are still MF tools. They have their inconsistencies, as far as wheel counts, even though they got multiple counters, and also MFL, how it reacts to different pitting, particularly the aspect ratio of pitting. And if you look at this this aspect ratio, this would be something what they call a 3-to-1. But what happens if you got something that's like AC corrosion or microbial induced corrosion, where you have steep and deep pitting? Well, that is not your typical 3-to-1 ratio, that it's set up on. So keep in mind there. This is why we do this is why we do verification digs, to prove up that the ILI tool is correctly reading the depths and the lengths, and how the clusters, and how do you match up those clusters of pits using your interaction rules. Okay.
Awesome. Well, we may only have time for one more question. There are quite a few, so we'll try to reach out after this webinar to try to answer any that we don't have time to get to. But I have this question here that I'd like to talk about. This is, how does RSTRENG differ from the P-square method of assessment?
Well, the P-square is more on the line of statistical analysis, and whereas RSTRENG is focused on the actual actual measurements themselves. I'm not saying P-square is looking at many things that that RSTRENG doesn't take for granted. In other words, RSTRENG has a built-in conservatism because of the unknown metallurgy. And this is probably maybe why some of the operators are a little bit reluctant to start using P-square, because do we really know our metallurgy as well as we should? We're just beginning to, understand and determine, the grade of pipe, because some of this is still unknown. And if you don't have it documented, you're going to have to default to 24,000 yield. So there's a lot of unknown metallurgy. There's a lot of unknown cracking that occurs due to secondary stresses and things of this nature. Do we really know our pipeline like we should? I said, and that's the question you have to ask yourself. If you do, I think probably P-square would work very well. But if you don't, like most operators, they're still learning about some of the cracking, unanticipated cracking that sometimes occurs, even on new pipelines, for various reasons. So I just leave it up. This is an operator decision. They have to look at and make their own decisions.
Joe, if I could jump in real quick, I know we're about out of time, Adam, but I would say that on that P-square, it was I would call it formally accepted, deployed through PRCI a couple of years ago now. So relatively speaking, it's still in its infancy. But what we've done is developed a users group to start talking more about that, to get a better understanding for deployment, for utilization, and truly figure out from a PRCI perspective, what should we be doing for deployment in software as a comparison, as an example between B31 and RSTRENG, and then having P-square as an example. Not saying that's the direction we go, but
Yeah.
we do have a users group on that. So if there are members on that are interested in that, they can reach to me or Adam, Joe. If you guys intercept those, certainly send them my way as well.
Absolutely. Yes, and we need to be looking towards the future. You know, I'm not saying which one's more accurate. It's again, it's I just know some of the operators are concerned sometimes, even with RSTRENG today. So, you know, about not being conservative enough. So I get some questions like that. You know. But anyway, yeah, they were great questions, and this is the way we need to be looking. You know, when we feel, you know, when we could use the appropriate assessment methods, and that's why we have multiple assessment methods, you know, all the way through, and we're going to continue to see them. You know, whether it's the shell, the DMV. The RSTRENG or the ASME B31Gs, you know, or modified, whatever it is, P-square, we need to fit that to the particular line and materials that you're dealing with. Thank you very much.
Okay, well, unfortunately, those are all the questions we have time for. There was one right at the end that was asking if the units can be changed to metric, and the answer to that is yes, just to get that clarified for anyone that may still be wondering that. But I want to thank everyone for attending. It really meant a lot that you attended this webinar. We try to do them fairly regularly, and I, of course, want to thank our speakers, Gary and Joe, and, of course, thank PRCI as an organization for collaborating with us on this. It's been great working together on this. And, you know, we have an RSTRENG and defect assessment class coming up on December 14th that awards professional development hours. That's taught by Joe Pikas as well, where he'll go into a lot more detail. But overall, thank you everyone for joining, and you'll receive a recording of this webinar sometime today. Thank you.